In this problem, we need to prove the following. So let's start from the left hand side of a given equation. So we have on the left hand side sine theta raised to the power of 8 minus cosine theta raised to the power of 8. Now we can also use the property of indices and rewrite this expression as sine theta raised to the power of 4 whole squared minus cosine theta raised to the power of 4 whole squared. Here we will be using the property a squared minus b squared. This can be also expressed as the product of a minus b and a plus b. So in the case, a is represented by sine theta raised to the power of 4 and b will be cosine theta raised to the power of 4. So this is going to give us a value sine theta raised to the power of 4 minus cosine theta raised to the power of 4. So this will get multiplied to sine theta raised to the power of 4 plus cosine theta raised to the power of 4. Now we can again rewrite this particular expression as sine squared theta whole squared minus cosine squared theta whole squared, which will be multiplied to sine theta raised to the power of 4 plus cosine theta raised to the power of 4. Now sine squared theta whole squared minus cosine squared theta, again we can apply this particular property. So this can be now expressed as sine squared theta minus cosine squared theta multiplied to sine squared theta plus cosine squared theta. So this is the expression of this particular expression. Now this will get multiplied to sine theta raised to the power of 4 plus cosine theta raised to the power of 4. Now we have the standard trig identity sine squared theta plus cosine squared theta. So this value is always equals to 1. So that means sine squared theta plus cosine squared theta, this value will go to 1. And we can now rewrite the expression as sine squared theta minus cosine squared theta multiplied to 1. So we don't have to write to the 1. So this will simply get multiplied to sine raised to the power of 4 theta plus cosine theta raised to the power of 4. Now, if we look at the right hand side of the equation, so we have a sine squared theta minus cosine squared theta, which we have obtained, but we will have to now work with sine raised to the power of 4 theta plus cosine raised to the power of 4 theta to make it into this expression, which is 1 minus 2 sine squared theta cosine squared theta. So let's work on that. Now, we'll keep the first expression as it is. We have sine squared theta minus cosine squared theta. Now we're going to manipulate the expression. So here we have sine raised to the power of 4 theta. So we have sine theta squared whole squared plus cosine theta raised to the power of 4 can be also expressed as cosine squared theta whole squared. Now we're going to add 2 times sine squared theta times cosine squared theta to it, but this is an extra term. We'll also have to subtract 2 sine squared theta times cosine squared theta. Now in doing so, we'll find that this can be now expressed as, so we have sine squared theta minus cosine squared theta. This entire expression, the first term, second term and the third term of this expression, this has the form a squared plus b squared plus 2 times a times b. So we have sine squared theta plus cosine squared theta whole squared minus 2 times sine squared theta times cosine squared theta. Now luckily sine squared theta plus cosine squared theta, that's 1. So our final expression will then become sine squared theta minus cosine squared theta whole multiplied to, so we have 1 squared, so 1 squared will be 1 minus 2 times sine squared theta times cosine squared theta. And this is the expression on the right hand side. Now since we have shown that left hand side is equals to right hand side, so we have successfully proved that the given equation is true.